Welcome to the Surgical Theater. Today we're bringing precision instruments and incredibly steady hands to completely dissect Cambridge Physics 0625 past papers. I'm going to show you exactly how to break down complex, intimidating questions with absolute surgical accuracy. And to do this, we're using the fascinating and often tricky topic of sound waves as our main operating subject today. Right now, I want you to picture something. Imagine a dynamic split screen in front of you. On both sides, there's a tension-building timer counting down, taking away the seconds of a real exam. On the left side of the screen, we have Alex. Now, Alex is basically a walking textbook. When asked a question, Alex just overloads the page with raw, unfiltered physics facts. He throws everything at the wall, but he completely misses the actual analysis. Now look at the right side. On the right, we have Sam. Sam is quick. Sam is incredibly smart. But Sam rushes under the intense pressure of the clock and totally misses the specific requirements hidden in the command words. So what happens? When their papers come back, both are just covered in brutal red pen marks. Neither of them achieved the top grade they desperately wanted. Well, today, we are going to fix that. We're going to transform those red marks into green check marks. Let's dive right into this and explore exactly what the principal examiners are actually looking for when they grade your paper.
Okay, you might be looking at this and wondering what this massive number 15 actually represents. Well, mastering this single topic of sound, its production, its transmission, its properties, along with the specific analytical methodology required to answer questions about it, accounts for a massive 15% of the total marks in their physics examination. Let that sink in for a second. 15%. That is literally the difference between passing and failing. That's the heavy, solid barrier standing between a B and that coveted A star. Both of our students, Alex and Sam, lost crucial marks in that 15% margin. And here's the kicker. It wasn't because they didn't know what sound was. It was because they didn't know how to systematically process the information in the very specific way that Cambridge examiners demand. This explainer right here, this is your ultimate blueprint to capturing every single one of those marks.
So here's our structured blueprint for today. We're going to move logically from the theoretical foundations of sound in Section 1 straight into the strict procedural framework in Section 2. Then we'll tackle how to evaluate evidence quality, and finally, we'll cover the top examiner warnings so you don't fall into the common traps. But listen, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you're going to want to have these strategies locked in for every single topic. Okay, let's get into it.
All right, moving right along to Section 1, Core Principles of Sound, our theoretical foundations. We absolutely must establish the strict physics knowledge and understanding parameters that Cambridge requires before we can even begin to analyze them. Okay, these right here are the absolute foundational facts of sound waves, pulled directly from your syllabus. First, sound is produced by vibrating sources. Second, it has a longitudinal wave nature. This means the particles vibrate parallel to the direction of the wave travel. Think of a slinky being pushed back and forth. Third, the human audible frequency range sits precisely between 20 Hz and 20,000 Hz. Anything outside that we simply can't hear. Fourth, and this is a big one, it critically requires a medium for transmission. It absolutely cannot travel through a vacuum, like outer space. And finally, the speed of sound in air ranges between 330 and 350 meters per second. To put that into perspective, that's like traveling 3 whole football fields in a single second. Now, this is exactly where our student Alex goes completely wrong. Alex memorizes this exact bulleted list and thinks, great, job done. So when an exam question asks about an experiment using a ringing bell placed inside a vacuum jar, Alex just scribbles, requires a medium, and quickly moves on. But the examiner? They are looking for a connected, conceptual understanding. Why does it require a medium? How exactly do the vibrating sources create those compressions and rarefactions in the air? You must memorize these facts for sure, but you have to use them as solid building blocks for your analysis, not just random trivia to recite.
Because here's the secret. Top-performing candidates don't just stop at basic knowledge. They move seamlessly through target cognitive domains. They transfer these basic principles across distinct areas into completely unfamiliar, complex contexts. And this right here is exactly where our second student, Sam, struggles. Sam rushes. Sam completely misses the command words in the question that explicitly tell you which cognitive domain you need to operate in. If the command word is state, sure, you're in the first domain, just give the fact. But if the command word is explain or analyze, you literally cannot just drop a fact and run away. You'll lose the majority of the marks. To perfectly bridge this gap, the absolute top students use what we call the PEEL framework. That stands for point, evidence, explanation, and link.
First, you make your point about, say, the longitudinal wave. Then you provide evidence from the specific data given in the question. Next, you explain the physics behind the particle vibrations. And finally, you link it all back to the specific context of the question being asked. I really want you to mentally visualize this structure. As we look at different answers today, challenge yourself. See if you can spot which answers successfully follow this peel structure. It is a total game changer. It will completely transform how you approach your written responses.
Let's move into Section 2, the procedural framework, or our technical methodology. This is exactly where we shift gears from simply what to know to exactly how you systematically process it under the intense pressure of exam conditions.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, to capture these maximum marks, you absolutely must internalize this standardized 5-step procedural sequence. Step 1. Identify the key elements from the text or table. Step 2. Apply the relevant physics principles. Step 3. Execute your analysis with crystal clear working. Step 4. Verify your results. Step 5. Present in the appropriate format using highly professional terminology. Let's do a live interactive workshop right now, a data scan and transformation challenge. Imagine a really complex data table about a ship using sonar to detect the seabed. The data tells us sound travels at 1,500 meters per second in water, and the echo returns in 0.4 seconds. The command is to calculate the depth. How does Alex handle this? Alex just grabs the numbers, multiplies 1,500 by 0.4, and slaps down 600 meters. 0 working shown. And he completely forgot that the sound had to travel down to the seabed and then back up. Wrong. Now, what about Sam? Sam rushes, realizes it's an echo, divides the time by 2 to get 0.2 seconds, multiplies by 1,500, gets 300, but totally forgets to write the unit of measurement. Both of them lose crucial marks. Now let's rewrite this perfectly using our blueprint. Step 1. Identify the key element. It's an echo, so the wave travels twice the distance. Step 2. Apply the principle. Speed equals distance over time. Step 3. Execute with clear working. Write down distance equals speed times time divided by 2. Step 4. Verify. 1,500 times 0.4 divided by 2 equals 300. Step 5. Present format. 300 meters. The M for meters is absolutely crucial. By systematically following these exact steps, you literally watch those red pen marks transform into green check marks right before your eyes.
The absolute most crucial takeaway here is what we call the method mark strategy. Listen carefully. Cambridge heavily emphasizes procedure over the final product. The awarding of marks is very often just for demonstrating the correct systematic process and showing clear working, even if you make a silly calculator error at the very end. Your systematic analysis, your deliberate use of appropriate terminology, like saying longitudinal instead of just sound, or compressions instead of squished together, and your evidence-based reasoning, these are exactly what earn you the points. This strategy is quite literally your ultimate defense mechanism in the exam room. When you show the examiner exactly how you logically arrived at your conclusion, you're proving your deep cognitive understanding of the physics rather than just guessing a random number. When you secure those method marks, you are essentially bulletproofing your exam paper.
I really need to hammer home this massive examiner alert. Read this quote. Even if your final answer is wrong, method marks can save you. Principal examiner reports constantly, year after year, highlight that students lose easily attainable marks simply by leaving their working space blank. It's tragic. Imagine this. You write down the perfectly correct formula. Let's say V equals F lambda for wave speed. You substitute the correct frequency of 20,000 Hertz. But then, your finger slips and you hit the wrong button on your calculator under the stress of the timer. If the examiner sees your correct formula and your correct substitution written down, they will still award you method marks. But if you just confidently write down the wrong final answer with absolutely zero working, you get a 0. Always show your working. It acts as a critical safety net that catches you when you fall. All right, this brings us to Section 3, Evaluating Evidence Quality. We're talking critical analysis. Now, we are officially entering the highest tier of assessment. This is exactly where we separate the basic passes from the elite top-tier A-star grades. Let's do another workshop challenge. Find the flaw. I want you to imagine a complex data table measuring the speed of sound in air at various different temperatures. A student with basic interpretation skills just extracts a fact. They write, at 20 degrees Celsius, sound travels at 343 meters per second. Okay, fine. But what if that same student writes a paragraph claiming that this single specific data point definitively proves a massive scientific hypothesis? If you look at the examiner commentary for an answer like that, they would absolutely rip it apart. That's the flaw. Top-scoring candidates who actually use evaluative thinking wouldn't do that. They would actively question the assumptions. They would identify the limitations of the experiment. For example, they'd point out the human reaction time of the person using the stopwatch to measure the sound traveling. That reaction time introduces huge uncertainty. They would state that the data only shows a general trend where speed increases with temperature, rather than proving a single absolute value. The absolute best students justify their decisions by proving they understand how the limitations of the physical experimental setup, like the distance being way too short to get an accurate human time reading, drastically affect the final conclusions. That is the fundamental difference between just blindly extracting data and critically evaluating evidence.
Let's move to our final section, Top Examiner Warnings. We need to talk about avoiding common traps. The information here is drawn directly from the Principal Examiner reports, specifically for the 0625 syllabus, so pay close attention.
Okay, look at this table. This is essentially your ultimate cheat sheet for exam survival. Let's break down the top mistakes and contrast them with the strategic fix. First major trap, using the wrong approach for the context. Students so often panic and try to apply a formula or concept meant for light waves directly to sound waves. The fix? Apply our standardized procedural framework. Identify those key elements first to ensure you are operating in the correct physics domain. Second trap, forgetting to check format and presentation. This looks like writing, "the sound gets louder," instead of using the actual appropriate terminology like "the amplitude of the longitudinal wave increases." The fix here is entirely about maintaining professional scientific presentation. Third trap, answers are not specific to the context given. This is when a student just writes down a generic, memorized definition instead of actually applying it to the specific submarine or musical instrument or whatever context is given in the prompt. The fix, justify your conclusions with specific evidence extracted directly from the text provided. Let's do a 30-second speed writing challenge right now. Think about how you'd perfectly execute a Peel paragraph under time pressure if the exam asked you to explain why sound travels faster in steel than in air. Here's how you do it. Point, sound is a mechanical wave requiring particle interaction. Evidence, steel is a solid, air is a gas. Explanation, particles in steel are packed closely together, allowing vibrations to transfer energy much faster than the widely spaced particles in a gas. Link, therefore the speed of sound is significantly higher in the solid medium of steel. Boom. Perfect marks.
So, after everything we've covered today, I leave you with this final, highly provocative question. Is your procedural framework actually ready for the exam? When you sit down with that paper and the timer starts, are you going to be an Alex, just nervously dumping raw facts onto the page? Are you going to be a Sam, rushing without any structure and missing the command words? Or are you going to approach it with the steady, calm hands of a surgeon, systematically analyzing the evidence, using the Peel framework, and securing every single method mark available? Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. I'll see you in the next explainer.